Okay, so I got the house key.
Oh, yes, and we're recording. Welcome, everyone. Does anyone want to do the host role today?
You do it.
Okay, I'll do it. We have a list of topics on the agenda, starting with review the current dev focus and blockers. Should I pull this project board up for discussion, or should we start with the Helm OCI? What do you think?
Let's start with the board.
Okay. So this is the maintainer's focus board. This is linked from the agenda notes here. Would anyone like to talk about any issues in particular?
Yeah, so we have moved forward with experimental managed transport and we fixed some issues for on-prem GitLab clusters that were timing out. So now we are doing, we are discarding the timeout errors and we retry the connection. So it's kind of a self-heal connection. Another thing that we did was for providers like Azure DevOps that don't like the keep reusing the TCP connection for multiple operations. So now we no longer cache the connection and we close it and we reopen a new one. So hopefully in the next Flux release, we'll see more reliable experience when using libgit2 for source controller and when using image automation, because image automation only uses libgit2. We want to talk about the refactoring, Hide, where we are, what's the next plan?
Well, the things I had planned to do are basically took a side route due to the SOPs and the decrypted things from Customize. So other than the update from last meeting, which was basically that I was going to move on onto the Helm controller, that basically hasn't happened. I'm going to finish the customized controller work now and then continue to move on to the Helm controller. And that's about it.
Cool.
Sunny might have to tell something about the image automation controllers he's working on, because that had a PR pending. And he started picking that up again now that the source controller is 100% done.
Great. Yeah, we should also mention that we've created a project for general Flux GA, which means 2.0.0. And in here, we are currently adding things that we consider that must be done before the GA release. One important feature that we want to ship before GA is adding OCI support for Helm repositories. I have proposed a solution for how to modify the API in order to have this support. It's a tiny change to the Helm repository custom resource where a new optional field was introduced in the spec. The field is called type. When you specify type OCI, then you can provide the URL and credentials to the container registry where your charts are. And then in Helm release object, instead of, you just refer that Helm repository the same way you did before. The only detail is that instead of going to a HTTPS Helm repository, it will go to the OCI address. But from a user perspective, it's just drop-in replacement. You can easily migrate from HTTPS to OCI. And that's merged, and Sule and Max will be working on implementing this. I have created an issue in source controller, and I have assigned them there. Sule, can you say some things about what we decided around the implementation?
Yeah, sure. So what we decided is to go with the Helm getters. So today, what we do when we use a Helm repository, we use the Helm HTTP getter to pull a chart on its dependencies. With the OCI registry, what we'll do is that Helm has an OCI getter that works pretty much the same way that the HTTP getter, and we will use this getter to pull the chart from a registry the same way and then build it. I think that's not really difficult to implement because we have a chart repository today that encapsulates everything needed to use the Helm getter and then build the chart on its dependencies. So we could just reuse this, and instead of using an HTTP getter, using the OCI getter and adding, well, all the needed bits so to make it work. The only thing is, in the AFC, we are talking about having a new reconciler. Do we still plan to do that, or we can reuse the existing one and add just a new case for a new way of getting the artifact, the chart?
Yeah, I'm guessing adding a new reconciler, if we use the same getter, means duplicating all the code for nothing, right?
Depends the way, yeah, it would actually, I think it would be duplicating code. Because today what we have a switch where we say, okay, the source is a table or the source is from a Helm repository. If it's a table, we have a dependency manager that's pulling the chart on all the things. If it is a Helm repository, it's using the Helm getter to pull the chart, and then it's building your chart and putting it into an artifact in the storage path. And if you have a registry now, and if you have a new linker, I'm guessing we would do everything we do in the Helm repository switch. It's just that it would be, well, we would do everything the same because we would have to instantiate a getter, put all the options needed for the getter, and then use a chart repository to do the same thing.
Yeah, so we have in the Helm chart reconciler two functions, build from Helm repository and build from tarball artifact. So I'm guessing we could have build from Helm OCI repository, a different function, and which will be like copy paste of the current one and just change the getter from HTTP getter to OCI getter. So yeah, let's try this at first, and then
I think we can just try this. The only guardrail we need is, because now we won't be using index. So you have to make sure we don't load an index because we don't need it. That's the only thing.
Yeah, of course. And also the Helm repository reconciler has to check for the type, and if it's OCI, it will just validate the URL and do nothing. Set the status to ready and all the other conditions as it were creating an artifact, even if it doesn't.
Yes.
Hide, are you okay with going with the first implementation like this? Just creating a new build from function?
Oh, he did.
Opposed to.
So I pasted the link here. Opposed to creating a whole new Helm chart reconciler for OCA.
Yeah, it's fine. Did you take into account that a chart from Git can theoretically depend on an OCI artifact?
Can it?
Yeah.
And that's handled where? In build from artifact, right? Build from tarball.
Yeah.
No. So what you have is that there is a dependency manager, and the dependency manager accepts an injection of a callback function, which it calls while it's looking for dependencies. I think at present the logic is that it receives the URL of the dependency or of the Helm repository index, and then it tries to do a lookup based on an index which you set on the URL. So you would need to basically include the OCI repository types in the index, or either in some way that it can be looked up. And then if it finds the thing, then it composes a set of credentials based on the data of that object. And then it gives it together. So you would need to do a likewise trick, but then to configure what's the OCI library called again?
Horas?
Yeah, to basically configure the Horas getter.
Wait, who's sharing the screen here? It's you, Stefan?
Sorry, is it distracting? I'm in the wrong place. It's my screen.
Can you go back to the code, please?
Yep. Where would you like to see?
If you go to tarball, you have something. No, in the controller, yeah. Here, if you go to build from tarball, yeah. Just to make sure you understand. Here you have something, a dependency manager that's being set somewhere.
No, it's namespace chart repository callback. It's right after it.
So here you have dependency manager. It's about there. Yeah, here we set up the dependency manager, and then we put the namespace. Yeah. Right. And here
so
you go down.
Yeah, you need to. We fetch the secrets again for that particular dependency.
Yeah.
We detect which repository it belongs to, and then we build this one, right?
And then we create a chart. Here we create a chart repository, which is the URL of the repository that we get.
You need to detect the type, and then you need to construct the Helm getter options based on the type.
Yeah.
And then you need to also make sure that if you create a new reconciler for the Helm repository OCI type, I think the index is managed in the reconciler. I think it put it, or in this controller file. I think I especially put it here to deal with stuff like this. Let me check.
So what the dependency
So
means?
there is an index Helm repository by URL method, and that already takes the URL as defined in the spec. So you don't have to do anything. You just need to deal with the logic around constructing the credential set based on the type of the object, and the index is already managed for you.
Yeah, anyway, we can take this on our own. Don't have to scroll the code the whole meeting. So Sule, get in touch with Hide if you are stuck. And yeah, maybe open up.
I'll check the code out here with Max, and if you have any issue, I guess we will go and ask Hide for his help.
Yeah, what I would prefer is to open up pull request in draft mode without dependencies, just OCI getter, and then we can continue the discussion on the pull request itself.
Okay.
The main reason I want to do that as soon as possible is the fact that we have several users that were they had added OCI support to source controller, and we want to not waste their time, so they don't try to open their own pull request and so on. So we don't have to reject other pull requests, right? I've assigned the ticket to you, the issue to you, but maybe that's not that visible. If we have a draft pull request, that's more signals better that, hey, we are working on it and this is our top priority for source controller for now. I know a lot of users have been asking for this for months and months, and yeah, that's the reason.
Okay, so we talked about RFC 02, or do we want to have a more discussion about that before we move on?
No, I think it's okay. We have discussed it.
Okay, so the last issue on the topics is this link to good first issues. I'm not sure who put that there, but
yeah, I think it was Paulo's agenda item, but he's I think he's at the doctor's right now. So essentially, Paulo started filing a lot of good first issues. I'm planning hopefully today to get a blog post out about contributing to Flux, and we obviously want to send people to those good first issues. So if you have anything more to add, that's obviously greatly appreciated. Not quite sure what else Paulo had to say on this, but this is just my heads up. And sorry for being late earlier. Just noticed that Alex made it here. I'm not sure if Alex, you got to introduce yourself or say a bit about what you're up to.
Yeah, sure. Hey, my name is Alex. I'm working on an open source project called FluxDL, and I'm considering integration into the Flux City ecosystem, meaning that I might start to implement my own FluxDL controller. And today I'm just here to say kind of hi and yeah, get you guys to know.
Yeah, brilliant. Welcome to Team Flux.
Hello.
Do you have a link to your project? To add
Sure. It's just fluxdl.io.
How is it spelled?
KLUCTL. Let me try to figure out how to use the chat here. So it's currently, yeah, pretty unknown. It's a fresh project. Actually, not that fresh. I'm using it since quite some time, production as well. And now I'm at the point where I start to kind of promote it, do proper documentation, do a website, and trying to figure out how to integrate it with other projects and so on. And one of the main questions that many people get to me with is, what about GitOps? Like, does it work with Flux? Does it work with Argo CD? And so this is one of the next big steps that I have to do.
What was the reason for creating this Helm chart thingy? I mean, it's 101 with what Flux does,
No,
right?
I'm not sure at what are you looking right now?
At the Helm integration.
And it's so the idea is that the tool can be used from your local machine all the time. So you are not forced to use some kind of operator controller that does the deployments. So everything that you need is available locally, including all the handling with Helm and updating and stuff like that. And integration into a GitHub style system like Flux is optional for me. So that's the reason. So the focus is different. The focus is to be able to kind of have one command or a set of commands that allows you to control your deployments from your machine at all time. And having something that automates that in a GitOps style is then something I would kind of wrap around that. Not sure if I'm clear, if it's clear what I mean.
So you are going to build a Helm controller and a customized controller, which are separate from Flux?
It's a ClueCTL controller. So it's not going to call Helm or customize. It's going to call ClueCTL, which internally uses customize and Helm. So yeah, it kind of will do the same, but not really. Not sure how to explain that. I think it gets clear when you see example projects that use it. It's otherwise hard to explain why you would need something like that. So I'm currently working on multiple examples and migrating some open source projects to use ClueCTL. And I hope it will be more clear when you see them in action.
Yeah, it feels like a competitor to Flux, but yeah.
It's not. It's definitely not. It's like saying Helm is a competitor to Flux, which is not true because it's two different things, but they work together. So ClueCTL is going to do the same that you would normally. So let's assume you don't have Flux or Argo CD or anything. What you would normally do with Helm and customize, and whatever you use to orchestrate all that, so deploying everything in the correct order and stuff like that, that's what you would use ClueCTL for.
Mhm.
So, and then, as I said, then the next step is to integrate it into Flux, for example. So it's I think it's better to compare it to Helm or Customize instead of comparing it to Flux.
So you are going to use source controller and our custom resources for defining the source and all of that, right?
I assume. I didn't look that deep into. So actually into the code, I didn't look into the code at all so far. I just looked into basic architecture or basic documentation, how it works. But my current understanding is what I will need is I will need a controller that basically does the same as the Helm controller or the customized controller. I will probably have some issues with the source controller because ClueCTL is handling Git on its own. So inside the project definition, you can refer to other projects to pull in, for example, cluster definitions. And I'm not sure if this will be well integratable to the source controller. So that's something I have to look into details. But as I've just seen now, looking at the code that you scrolled through, it looks like the source controller is also handling pulling of charts. Is that right? Or did I misunderstand it?
Yes, yes. Charts,
so
customize overlays, Terraform, whatever.
So it's pre-pulling overlays that you refer from your customers, or how does it work?
It's pulling the Git repos where the overlays are.
Yeah, okay, yeah, I understand. So it might be that I also would have to change the source controller to pull ClueCTL projects, because pulling a ClueCTL project is not just pulling one repo, but it's pulling the repo and figuring out what are the dependent Git projects and then pulling them as well.
We already support that. We have an include Git repository, so you can bundle in a single Flux artifact multiple repos and include all those reports in a file system at a particular path.
Okay, that sounds like not that much work is needed there.
So I know my suggestion to you is, if you want to integrate this into Flux, try to work with source controller as it is without adding something to it that does the same Git pull and so on. We have been working for 2 years on a Git integration, and I don't think we are open to deal with something else that shells out to Git or whatever. Our code is very sensible in that direction. We have a managed library and an unmanaged library for dealing with Git. We use GoGit, we use libgit2 with C bindings and so on. Adding a new way of dealing with Git is not something we'll accept.
I'm using GoGit as well, so I stopped shelling out to Git a few months ago for different reasons.
And how do you manage Git protocol version 2?
Git protocol version 2?
Yes, like Azure DevOps and other Git servers. Azure DevOps, for example, knows only about Git protocol 2, and there is no Golang implementation for that. You have to use libgit2, OpenSSL.
Yeah, that sounds like I'm not handling it at all, because I'm completely relying on GoGit doing Git protocols.
Yeah, I mean, there is a, have you seen this tutorial?
Are you going to mention the blog post? Daniel just linked it in the chat.
Okay, paste the link here on how you can write a bare controller with no API at all that watches for sources from source controller, and Flux integration should start with that. Also, getting familiar with Flux and all that it does, it will help a lot.
Yeah, sure.
Clear some.
Yeah, I'm definitely even less than a newbie to Flux. I didn't even install it yet, to be honest. Might sound strange to plan to start a controller without having Flux ever used, but
right.
But that's something I have on my list for this or next week. To actually, I have Flux installed, but I don't actively use it.
I saw that ClueCTL uses server-side apply, and that was one of the reasons why you're here, because server-side apply is not widely implemented by a lot of other solutions in the space.
Yeah. So I started using server-side apply quite early and figured out that even kubectl, for example, doesn't implement it in a way that is, yeah, how to say it, that is practical in day-to-day business. Because very often you get into a state where you are forced to do a force apply, and you take quite some risk when doing that. So I have my own conflict resolution implementation inside FluxCTL that tries to not fiddle around with stuff that definitely doesn't belong to FluxCTL, or stuff that was claimed by some other operator, controller, or even CLI tool. So the idea is that whenever someone else changes something that I've deployed before, FluxCTL will tell me that it knows about that change. It knows someone has touched it, and it will tell you that it will not touch it until you force it to do that. At the same time, you have multiple annotations on objects that control that behavior. For example, if you know there is a misbehaving operator that keeps fiddling around with field managers and kind of overwriting field managers where it shouldn't do that, you can tell FluxCTL through annotations that this is one that can always be force applied just on that field, not the whole object. So yeah, I think that's quite crucial.
Yeah, we have a totally different approach.
What's your approach?
Flux is the sole manager of everything on a cluster, because that's
Okay, so
that's GitOps, right? All the things have to be defined in Git, and it only tolerates other managers which are in cluster, not outside the cluster. So Flux, for example, will not tolerate any kind of CLI that doesn't apply on the cluster. And yes, we have our own server-side apply implementation built 6 months ago.
It doesn't tolerate means it will overwrite everything, or?
Yes.
Okay, even if, let me try to find an example. I'm not sure if it was the elastic operator as an example, which keeps overwriting fields and changing field manager. I mean, ownership of fields. Even in that case, you would just simply overwrite it?
Yes.
Even if shortly after that, the operator again overwrites the value?
The main idea of GitOps is that your definition is in Git, and that's the canonical source of truth. I know we have some, I don't know if it's exceptions, but there are cases like where the persistent volume gets its owner ref written. That's by kube controller manager, right? Those things are permitted. But yeah, we've wrangled with this issue a lot, and what you mentioned about kubectl, not their implementation of conflict resolution not exactly being optimal, that rings pretty familiar.
Yeah, it's very naive. Like, you just have two options: overwrite everything or accept that you cannot do anything. So
yeah, we undo all the things that are performed from the client side. For example, if you add an environment variable or an init controller to an existing deployment, and if that deployment is managed by Flux, Flux will delete those fields, even if they are not defined in Git, because the omission of not being in Git means I don't want those stuff on the cluster. But if, let's say, the autoscaler adds things like replicas, even if replicas is not in Git, will allow that field to be added on the cluster. And we also have annotations for for allowing Flux to merge, to do the three-way merge for cluster add-ons like Core DNS, CNIs, and other things that come directly with the cluster when you create it. Because we cannot just delete Core DNS and recreate it, or the CNI. So we tell people, hey, add this annotation. We are going to tolerate this particular add-on being managed by EKS Scuttle, for example, and stuff like that. But yeah.
How do we determine which fields should be left and which fields must be deleted or overridden? Do we have a kind of a whitelist of field managers, or?
We are going to expose that at some point, yeah. We don't have, well, that's not something you can configure right now. What you can do is annotate a particular resource in Git. So you define Core DNS again in Git, and you tell Flux, hey, merge this one instead of taking full control of it.
No, what I mean is, you gave the example of replication fields, for example, being added, and in that case, Flux would not delete them.
Yeah, because it's not in Git.
So there's an internal whitelist of controller manager and other.
Okay, that was the question. So you have a whitelist. Okay.
Yeah.
So on omission from Git is allowed only if the manager is not kubectl server-side apply, client-side apply, and there are a bunch of managers that kubectl sets, or the API sets when it migrates kubectl from client-side apply to server-side apply. So all these managers are, let's say, blacklisted, denied override, unless you tell Flux, allow all these changes and do the merge for me. And that's made for cluster add-ons.
Okay, for ClueCDL, it's the other way around. I have a whitelist of field managers that ClueCDL can always override. So for example, if it sees a change comes from kubectl or from K9S or from whatever, so stuff where you know this is someone manually fiddling around with your resources, this is something ClueCDL will always override. For everything else, it will check if the value has actually changed, and if yes, it will inform you that it's not going to touch that value. So it's kind of the other way around. The reason for that is, I mean, I understand that if you want to do GitOps, the only source of truth is Git. That's the idea. But at least from my experience, you still always have situations where something in the cluster changes stuff that is not in Git. So for example, there are many operators which do stuff to your resources that you would not expect, or where webhooks do stuff, so mutating webhooks that do stuff to your objects that you did not expect. And the target is to let live and live. That's kind of the idea behind that.
We'll never do that. That goes against everything we've built. So
okay.
I think Tecton is an example of one that writes back to its own custom resources for some reason. It's very difficult to understand why.
I know many examples that do that. I cannot name them by name, but so in the projects that I worked, there were a lot of examples where stuff like that happened. Even simple stuff like you write like a volume size. You say you want 1 gigabyte, so 1 G, and after it's applied, it is changed to 1000 M. Just as an example, some operators do stuff like that. I mean,
okay.
That's okay. It's minor. You could just ignore it, but
no. Flux will detect that change and will allow it, because that transformation happens at the at the API level. So Flux does not compare what's in the cluster with what's in Git. Flux compares what's in Git after cluster mutations with what's in cluster. So if a mutation transforms something from gigabytes to megabytes, that's fine for Flux.
So long as it happens at a admission
Yeah,
and
exactly.
not later on. Something
Exactly.
comes back and writes back to the spec.
Oh yeah, yeah.
Section
We don't
that's-
accept writing back to the spec unless there is a field which is not specified in Git. Because you cannot have GitOps while you specify something in Git and that thing changes in cluster. And I mean, there are thousands of Flux users which use all sorts of controllers and no one noticed any issues. We have Flux with Tecton, with you name it. Usually, even if a controller writes back, for example, the kube manager will always write back to the spec of a service. In the body of the service, it will add the cluster IP and so on. That's okay because then you don't specify the IP in Git. If you specify the IP in Git, that means, hey, that should be the IP of your cluster. No one should change it afterwards, right? So it's up to you to decide which things you want to enforce and which things you want to have a policy. I don't know, something like I don't know, Istio virtual service that defines how IPs are allocated or whatever, right? And Flux will just tolerate those because they are not in Git. In Git, it's only the policy of that, the desired state of that object. Also, it's the same with Flagger, right? That creates a bunch of services, other deployments, alters the original deployment, but only does that on the fields which are not in Git. Okay, let's move over to another topic. We have only 10 minutes left. Is there anything else on the agenda?
That was the last topic on the agenda, unless anyone has anything to add at the last minute here.
Hide, do you know when we are going to do the next release?
Early next week. We have Easter coming up, so it's better to lift it over the weekend.
So do we want to? So the next release will also include the customized controller SOAPs improvements?
Yeah.
Oh, great.
Okay, is there anything else?
Yes, I would like to encourage people to review the next RFC around the OCI support for Kubernetes manifests, where the proposal there is to offer a different API type that you can replace Git repositories with OCI repositories. So instead of telling Flux, hey, go and fetch this overlay or whatever, these YAMLs from a Git repo, it should do that from an OCI repo. And let me paste it here. There is an implementation, there is a pull request made by tons of people from VMware around this. I have, cycled back and made the final proposal around the API and how it should look. There are still some discussions around supporting MTLS when connecting to an OCI repository. Do we want to have a service account name? So basically you'll look up a service account name to get the pull secret, the TLS, the client cert, and so on, instead of just referring to a simple Kubernetes secret and so on. So there are a lot of things in here that I would really like some feedback when you have time. Tariff C is not fully written yet. I still have to come up with different user stories, but our goal is to have Flux, the CLI, being the tool that builds customized overlays or whatever is there into OCI tarballs. Also, Flux, the CLI, like Docker, will push and pull these tarballs to container registries, so you can, in your CI pipeline, like you currently do with source code, that you do a Docker build and a Docker push, you'll do the same for your manifests. You'll do a Flux push of a particular directory where all your manifests are. And on the server side, source controller, we have an OCI repository custom resource where you say, hey, pull this artifact from this repository. And then you can use image automation controller, and you can say, on my production cluster, I want to deploy only stable Semver releases. And on my staging cluster, I want to deploy release candidates. And this is not about application containers. This is about the whole desired state of the cluster, right? So you can migrate, you can do promotions with image automation controller, which creates pull requests. Let's say you release a new stable version of your desired state, then image automation controller will open a pull request on your production branch, and it will say, hey, I have this new version. I've detected this new version of the whole thing, the whole definition. And when you merge it, only then all the things got promoted from one stage to another. So it enables a better control around promotions, and it also makes Flux more snappy, let's say. So right now, what I have talked to a bunch of Flux users in the last 2 months, especially those that use Flux at scale, Flux on hundreds of clusters, Flux that manages thousands of applications and Helm releases. And the feedback was, when people use a monorepo to define the whole thing, every time you change something in that monorepo, then we basically trigger a server-side apply dry run for everything that's in there, right? Because we get a new revision, that means all the customizations have to figure out, because their source has changed, a new revision is present, they have to do a dry run and determine, is something changed in my particular overlay or not? So to solve this issue and not trigger like a whole spectrum of server-side applied dry runs, in the monorepo, you'll just refer to each OCI artifact of a particular app. And then when you push the OCI artifact to the registry, notification controller tells Flux, hey, there is a new change, but only for this app. So instead of doing this dry run for the whole cluster, you'll only do the dry run for a particular application and only for that change. So it's way easier on the Kubernetes API side, and it makes Flux way faster. That's the end goal for this. So yeah, I'm looking for feedback on the current spec of the proposal. That's it from me.
This feature and the Helm feature together are two that I'm really looking forward to personally, because it's going to make teaching people about automation and Flux so much easier, because you can generalize image update automation and just use it for OCI resources. And I think you have a demonstration of that in the first RFC that we saw earlier.
Yeah, we can drive all changes through pull requests now because of reusing image automation controller push feature. That's one thing, and also think it's super important for OCI is super important for running Flux at scale because, as you know, the Helm repository does not scale. If you have like the index YAML can, if it gets over 15 megabytes, your controller will use gigabytes of memory. You'll have a bunch of issues because every time you want to do a release, you have to look up the whole index file, you have to extract that version from there and so on. So it's a huge bottleneck dealing with Helm repositories that have thousands of charts and many thousands of versions. OCI solves that because there is no more index YAML. Basically, the Helm repository is just a reference now to authentication, credentials, certificates, and so on. And the lookup is based on directly with the OCI client. So for Helm means way less resources used to look up versions and build charts. And for applying customizations, for applying the whole desired state, Helm releases and everything else, that now must come from a Helm from a Git repository or from an S3 bucket. We offered this third option to come from an OCI artifact that can be signed with cosign. We are going to verify the authenticity of artifacts before we apply them. In the same way we do today with OpenPGP and Git, we verify the commit is that person that has changed something in Git allowed to change something in the cluster. Now we can do the same, but without OpenPGP, with the modern tools like cosign and verify the authenticity of the thing that has built the image and has pushed the image to the registry. So yeah, I'm super excited about OCI in Flux, but we'll see when we can deliver all of this.
Great. Well, it's the top of the hour. I think that means we're out of time. Thanks everyone for joining us.
Thanks, Alexander, for tagging along and explain us what your project does. It's very interesting.
Thanks for listening. See you guys. Bye-bye.
Bye, everyone.
Bye-bye.